Okay, this video is all about distance between 2 points, working with equations of straight lines, working with gradients and perpendicular lines. So before I look at some exam questions, I'm just going to go over a few things. First of all, to find the distance between 2 points, so they'll normally say this is point A, this is point B, and work out the length of that line. So what I like to do first is just to quickly sketch it. So I draw some coordinates, and the first point is minus 15, 2. So if there was minus 15 and here is 2, I know that point was there. And the other one is 35, 17. So if this was 35 and up here is 17, I know that point is about there. So we're looking at this line here. So I basically want to calculate the length of that line. And to do that, we use Pythagoras. So if I was to turn this into a triangle, that will always be my hypotenuse, because it's opposite to my right angle. So I want to just use Pythagoras now to solve that length of that line. So I know this length here is going to be the distance from 2 up to 17. So that length there is 15, because if this is 2 and this is 17, I know that goes up 15 points. This bottom line now, so this one is minus 15 and this one is 35, so I know that length is 50. And just with a triangle, just Pythagoras now, I know that this length, the one we need to try and find, the distance, is going to be 50 squared plus 15 squared. So this is just Pythagoras, where a squared plus b squared equals c squared, so I'm going to do 50 squared plus 15 squared. Don't forget you've got calculators in additional maths, so you can use them wherever you need to. Sometimes they do ask for insert form, and you can just use your calculator and just, cheat essentially. So at this point we need to square root it, because if a squared plus b squared equals c squared, this is currently c squared, so we just need to take the square root of it to find our length. So the square root of 2725, and my calculator gives me the 5 root 109. I'm just going to press SD to get 52.2. So that is the distance between those 2 points, and they normally ask for inner length, so I'm going to add centimeters. Okay, so that's the distance between 2 points. Working with these things, they might ask you to find the gradient of a line. So when you're looking at a gradient, so for example, if I've got work out the gradient of the line joining these 2 points, gradient is how steep something is. So once you've drawn it, you could kind of see. So if I start again and I'll plot these 2 points, I always like to do this to see which direction the line is going, so you can see if you've got a positive or you've got a negative gradient. So if your line goes up like this, that's a positive gradient, or if your line goes down, it's steep, it's going negative, it's going downhill, so that is a negative gradient. So you work out your gradient and then you decide if it's positive or negative, just depending on which way it's facing. So if we plot these points, so I've got 3, minus 5, so 3 was here and minus 5 is here, just roughly plotting them. I'm not going to draw out a whole coordinate sheet, I just do this to find out if it's a positive or negative gradient. And the next one is 7, 13, so 7 is here, and 11, I said 13 then, didn't I? 7, 11, so this one is going up, so it is positive. The first one was also up, so that would also be positive. So you can do what we did above if you needed to, if you wanted to calculate the distance of that line, but you don't need to for the gradient. So the gradient is your change in y over your change in your x's. I normally display this in a triangle, so you might see me write change in y over change in x. So if we were to put it into a triangle, I know this length here is going to be my change in y. So from minus 5 to 11, so that length is 16. So I know this top number is 16. And my change in x is going to be this length. So from 3 to 7 is 4. So my gradient is 16 over 4, which is 4. So the gradient of this first straight line, so this line here, gradient of that line is 4. So it's got a steepness of 4. When you're working with a gradient, 2 lines are parallel if they have the same gradient. So lines are parallel, have the same gradient, because they would both go up like that. So their steepness would be exactly the same, or down. Perpendicular lines, so if we had a line that goes straight up and we found, okay, if from above the example was the gradient is 4, a line that is perpendicular crosses it, let me use a different colour, crosses it like that. So the first point to know from a perpendicular is it will have an opposite. Okay, so if this gradient was a positive gradient, then your perpendicular will be negative. So whatever it is, it'll always be opposite. And it's also the reciprocal. So it's the reciprocal of the line. So reciprocal is where we flip our fraction, basically. So if, for example, the gradient of this pink line was 4, the perpendicular, gradient of the perpendicular would be minus, and then the reciprocal of 4 is 1 over 4. Because the number 4 can be written as 4 over 1. Reciprocal is where you flip your fraction, and that gets you 1 over 4. Okay, so those are a few things about gradients and about parallel lines of the same gradient. Perpendicular is your opposite, so opposite of positive or negative, and then you flip your fraction. Another thing you're going to need to know how to do for these questions is to find the midpoint of a line. So midpoint is super easy. If you have your two coordinates, so let's start with the first one. The midpoint is the middle of those 2 points. So I like to add them up and divide by 2. So if you add up your x's, 2 add 6 is 8. So 8 half of 8, and 4 add 10 is 14, and half of that. So your coordinates of your midpoint would be 4, 7. So the middle of that line is 4 and 7. Super easy. I've included a negative one because, you know, some people get tripped up on negatives. So don't forget to add them and then half. So minus 5, add 5 is nothing. So it's nothing over 2. And then 2 add minus 4 is minus 2. And you still halfen it. So it's always half in it, always divided by 2. Therefore, the midpoint, nothing divided by 2 is still nothing, and minus 2 divided by 2 is minus 1. Okay, so midpoints of lines, when you come to see me doing one in the next examples, you just add them up and half it. Something you guys should already know how to do is equations of straight lines. So I taught you this way. They might ask you to rearrange it, but don't worry about that. You literally just move it around. So equation of a straight line is y equals mx plus c. M is your gradient, which we just found out how to do, which is your change in y over your change in x. And your c is where it cuts your y-axis. They would normally ask you to find the equation of the line that goes through a point. For example, so you would have found your gradient. Let's pretend our gradient is 4. So you would have y equals 4x plus c. And they would normally ask you to do it from the midpoint of the line. So let's say you worked out the midpoint is, let's use one of the examples, 4, 7. So you've worked out the midpoint is 4, 7. You know your gradient is 4. To find out this c, you just plug these into it. So you've got your x and you've got your y. So where we've got y, that's 7. And where we've got x, that's 4 plus c. So you know 7 equals 16 plus c. So to work out your c, you would just do 7 take away 16, which is minus 9. So your equation of your line is y equals, excuse me, very sorry, y equals 4x minus 9, and that would be your equation. Okay, so I've run over a few things there. I'm going to go through 2 examples, so 2 exam questions, and the rest of them you should be able to do by yourself then. So I'm going to do question 1 and 2 with you, okay? So question 1 says, the coordinates of the points P and Q are 2, 3 and 14, 19 respectively. Calculate the length of the line PQ. So this is exactly the same as the first step, the distance between 2 points. So I always start these questions by sketching it, rough sketch. So if this is 2 and this is 3, that point is there. This is 14 and this is 19. See, they're not, you know, accurate, it's just a sketch. So I know my line is coming up like this. If I was asked to find the gradient later, I know that's positive. So I'm going to turn this into a triangle. This side length here is going to be the difference from 19 to 3, so that is a length of 16. and this bottom length is going to be your different distance from 2 to 14, which is 12. So that goes across 12, and this one goes up 16. So to find the length of that line, I'm going to use Pythagoras. I'm going to do 16 squared plus 12 squared. So 16 squared plus 12 squared is 400. And don't forget, with Pythagoras, that's the square. So you want to take the square root of 400, which is 20. So the length of that line is 20. The next part of the question asks you to find the gradient of the straight line perpendicular to PQ. So this was PQ, we want the perpendicular to it. So first of all, we need the gradient of that line. So the gradient of PQ is going to be the change in the y over your change in your x. Change in your y is your green length, so it goes up 16, so the difference between those two is 16. And the change in your x is the pink line, so which is 12. You can leave it in a fraction, you can put it as a decimal, it is up to you. I'm just going to simplify it as 4/3. And we know that that gradient is positive, so that stays as that. So the gradient of the perpendicular, so like I said earlier, is going to be opposite. So that gradient of PQ is positive, so we know this one's going to be negative. And we just flip our fractions. So instead of 4/3, we get 3/4. And it is as simple as that. Next one's a little bit more complicated because they ask for an equation. Let's have a look. So the coordinates of the point A, B are 2, 8 and 4 minus 6 respectively. Calculate the length of the line AB. So this is exactly the same. Quick sketch to find out what it looks like. Some quick visual. So 2, 8 and 4 minus 6. So minus 6 is going to be down here. So I know that from that quick sketch, excuse me, I know the gradient of that is negative. I'm going to turn it into a triangle. So I go down and across. So this bottom length is the difference from 2 to 4. So that's a space of 2. And this y line is from 8 to minus 6. Don't put 2. It's not 8 take away 6. It's just how many points would be from 8 to 6. So you'd come down 8 and then down another 6. So that's 14. Okay, so that length is 14, not 2. You're not adding them. You're just finding like the difference between them. So from Pythagoras now, I need to do 14 squared plus 2 squared. So 14 squared plus 2 squared. I'm just doing this on my calculator because I'm lazy. Which is 200, and the square root of 200. You could leave it in surd form, or you could put it as a decimal. I'm going to put it as a decimal. They haven't specified, so I'm just going to go to 2 decimal places. So it's 14.14. And that's our answer. Next bit. So this one is 7 marks. Don't be scared by it. It is super easy. So find the equation of the straight line, which is perpendicular to AB, that passes through the midpoint of AB. Okay, so first of all, we want the equation of a straight line perpendicular to. So we know we need to do the perpendicular gradient, and we need the midpoint. So you need to find the midpoint to use those coordinates. So I'm going to just start with the gradient. So the gradient of AB from the line above would be the change in my y over my change in my x. So the change in my y is my green number, so it's 14, and my change in my x is going to be the pink number, which is 2. The line also goes down, so we know it's negative. So we know this one is negative 7. My voice is going. Sorry, excuse me. So the gradient of the perpendicular is going to be the opposite. So if this one's negative, we know the perpendicular of the gradient of the perpendicular is positive, and the reciprocal of 7 is 1/7. So we've got a gradient. We've got our m from our equation y equals mx plus c. We now need our midpoint. And don't forget, I'm just going to rewrite my coordinates. So the midpoint of 2, 8 and 4 minus 6. So 2, 8 and 4 minus 6. So to find our midpoint, we add them up and then half it. So 2 add 4 is 8. Is not 8. I was times in them, sorry. 2 add 4 is 6, thanks. Divided by 2, and 8 add minus 6. This is not now 14. This is 8 add minus 6, which is 8 take away 6, which is 2. and that is halved. Okay, so our midpoint is going to be 3, 1, because 6 divided by 2 is 3 and 2 divided by 2 is 1. So we've got our gradient, we've got our point. We now put those into our equation. So our equation is y equals mx plus c. This is your m. This is your x and y. So you input that and you'll be able to solve for c. So instead of y, I've got 1 from here. Instead of m, I've got a 7th. Instead of x, I've got 3. I'm just going to put that in brackets because there's a multiplying there. Plus c, the one we're trying to find. So we've got 1 equals 1/7 times 3 is 3/7. You can put it as a decimal if you want to, it doesn't matter. Plus c. And then 1 take away 3/7 will give you your c. So 1 take away 3/7 leaves you with 4/7 is c. Rewrite your equation. So rewrite this now with your m and your c. So the equation of the line is y equals 1/7 x plus 4/7. And that's your equation of your line. 7 marks. See, all we did was do a gradient, we did a midpoint, we put it into y equals mx plus c. Super easy. Okay, so don't forget to do those points.